mistakes in this program. Not every line is correct. Good morning. How are you? I invite you to draw the top stack so you know which one is supposed to be what. Any questions? You want to get started? Okay. Okay, if you just count, this is a practice. As I've said, there are some mistakes. What are the mistakes? Are you typing in the check?
Not yet.
Are you typing in the check? Not yet? What do you mean not yet? Do you have the answers? What I'm doing on the computer? You can check. Go ahead and type it in. Oh, you dressed well. Have you interviewed today? Hopefully. Oh, great. Good luck. What is the industrial round table? What is that?
In the fall.
Oh, how about the spring one?
Today. So that's today.
What?
That's expo. That's today.
That's today? Oh, okay. Good luck. Okay, I give you 2 more minutes. You know what we're doing?
I don't know what you're asking.
Okay, I give you some lines of program and ask you what happens. There are some mistakes, and for some of them, if they are not mistakes, what's the value of AC, PTR1, PTR2, and so on. Take out a piece of paper and write down your answer. Yesterday, a student that took 234 before came to my office, gave me some chocolate. I say I will share with current 234 students. So, if you want chocolate, speak up.
I want it.
You want?
Yeah.
You have to share with us your answers. Are you ready?
Okay.
Okay. Are you ready?
Sure.
So, you want to come over or you want to just read it? All right. So come over. Okay. So.
In line 11, it said point 1 equals to none. I thought it can be pointing to a non address. So consequently, number line 12 shouldn't be executed correctly. In line 15, the pointer of point 1 cannot point to the address of Z. So, and also in line 16, pointer 1 also point to a non-address, which is 3. This should get a warning. And in line 18, I feel like it's correct, but I feel weird about it. So I said if 18 is wrong, 19 is wrong. And then I think that's all of it.
Okay. Anyone else? Oh, okay. Keep going. Well, since you're the first one, you can pick two.
Okay.
All right.
I didn't have breakfast.
You didn't have breakfast. Okay. All right. For the people who just came, yesterday a former student from 234 gave me some chocolate. First, don't give me gift. Okay. Particularly if you are taking my class, I don't want to give you. That would be illegal if I get gifts from students. But since he's not taking my class, so I said I will give to students in 234 right now. Okay, so how about line 9? Is there any problem with line 9? No. Okay, so how do you solve this kind of problem? This kind of problem, you will draw a call stack. Let me give 500. It's A, and the variable is 5. So you have a simple address variable. Then line 10 is C. Let me give address 501, and the variable is -2. Line 11 say PTR. PTR, when you have integer star, means PTR's variable is an address. And that address stores an integer. There is a special address called NULL. It is 0. It is an invalid address. Means nothing in a computer is allowed to have this particular address. It is used as an indication of an invalid address. However, you can say PTR equal to, that is allowed, which simply says you cannot use PTR to get any data. It is allowed to put NULL here, but you cannot say PTR equal to something, because that means you want to write, in this case, write -7 into address 0. So your program will crash on line 12. Line 12 is a problem. If you're not comfortable with line 11 means the following two things. First, you create a pointer, PTR, and you say PTR equal to, you modify the variable. You never modify the address. Never, ever modify the address. You never have a chance to modify the address. If you try to modify the address, the operating system will stop you. Okay. Do I need to say it again? You never modify the address. It's impossible. Okay. You can only modify the variable. So if we say PTR, line 11 means this. You create a pointer, you put the variable into NULL. Because of line 11, line 12 will crash because you try to write -7 into the address 0. Star PTR, what does that mean on the left side of assignment? The address of PTR, anyone else? What does this line mean?
Whatever the address contains, you make it -7.
Okay, so I think everybody should read this class note and memorize it. Not memorize, not because you cannot look it up, but because it's like dictionary. If you look it up, you're going to be slow. Okay, this table 5.1 in the class note. You need to memorize it. You need to know this so well, and you don't even think about it. So the first one is creating a pointer variable because you have a type in front of star. So that's the difference between the first one and the other ones. You have a type. You are creating a type. The third one is the right side of assignment. You have equal sign there. You take PTR's variable as an address and read the variable from that address. And fourth is on the left side assignment. You notice there's assignment sign here. You take PTR's variable as an address and modify the variable at that address. I already said several times, memorize this table. If you want to do well in this class, otherwise you are going to look it up or you are going to forget. There are 4 different ways to use star or asterisk. You have to know which one is which. Okay. Any questions about this so far? Okay. I already said many times, memorize it. So, if you say line 12, line 11 says PTR's value is null, and line 12 says I want to assign -7 to the address, null. So the program will crash, guaranteed. Line 12 will definitely crash. So suppose we ignore line 12, then this is, draw the code stack again, A, C, PTR1. The pointer itself has an address. Everything inside your computer has an address. So this is a simple address variable. Currently A is 5, C is -2. Now look at line 13. Line 13 says PTR. Now notice PTR has no star in the left. Therefore you are modifying the variable here. So line 13 says PTR1 equal to %A. This means you take the address. So here will be 500. For those people not taking notes, I think you are making a mistake. You need to take note. Then line 13 is fine. There's nothing wrong with line 13. It's perfect legal code. Line 14 says PTR, star PTR 1 equal to 14. What does this mean? Is it legal? Is this legal code? Line 14.
It's actually just PTR.
I'm sorry?
In your code, it's only PTR, not PTR1.
Oh, okay. I'm sorry. 14 should be PTR1. Sorry. Okay. Add 1 there. All right. Thank you. Let's do it again. Okay. In case you want to know how to get the line number, there's a command called CAT. It means concatenation. It means merge 2 files. And -A means your line numbers. So line 14 says PTR1 star equal to 14. It is legal code. We get some volunteers. If you want chocolate, who has not had breakfast? Okay. You want chocolate? What's the answer? Line 14, is it legal?
Yeah, it's legal.
Okay. So what does it do?
It assigns whatever the value is stored in PTR1. It changed that to 14.
So which address will be changed?
The A is going to be changed. Little a.
A will be changed to
14.
14. Because you take PTR's value as an address, PTR's value is 500.
Yeah.
You modify the value at that address, so A becomes 14. Okay. Is line 15 legal code?
No.
Why is line 15 not? Why is line 15 a problem?
The answer sign is actually mean the address of it.
So the right side is means address.
But the left side asking the value.
The left side, this one you want to modify the variable. And since you already have star, that means you want to modify the value. This has to be integer. Therefore, you try to assign address to integer, you'll get a warning. Warning should be treated as mistakes. So line 15 is a problem. How about line 16? Is that line 16 good?
No.
Why not?
Because you're trying to access the memory address 3, it's going to cause a segmentation fault.
Okay, I actually says 3, sorry. Here, this line does not cause segmentation fault. Yet, not yet. This simply says 3. This says 3. That is fine. But why do you put 3 into a pointer? Why do you use a pointer? You want to use a pointer to refer to some memory location. You will either try to read it like this way on the right side, or you want to try to write it. You don't assign address to a pointer for no reason, do you? You have too much time to spend, right? You write code for some intention, with some purpose. So when you have a pointer, your intention is sometime later you are going to read, or you are going to write. When you read or you are going to write, that's the place you get segmentation from. So line 16 will give you a warning message. Compiler will say you are probably making a mistake. Line 16. How about line 17? Is line 17 good? Okay. Line 17 simply says PTR value is the address of A. So suppose we have ACPTR1. So 500, and I modified this to 14 already. That's a 501, 502, this is 500, because that's the address of A. And this will be -2. So line 17 says PTR is the address of A, so I modify this to 500. That's fine. How about line 18? Is line 18 good? Yes? Line 18 simply says I want to create PTR2. Line 18, you need to read line 18 as 2 lines, PTR2, and PTR2 is PTR1. So PTR2 has its own address, 503, and the value is the value of 500. You copy that. There's nothing magic about this line. Think about this. If you have integer x equal to 5, you say integer y, you say y equal to x. What do? You copy the value of x into a value of y. Right? There's nothing magic of this line. You copy the value of 500 to the value of PTR2. So line 18 is fine. How about line 19? What does line 19 do? I'm almost running out of chocolate, so if you want chocolate, you better speak now. What does line 19 do? Is line 19 legal?
Yes.
Okay. What does line 19 do?
Assign a value to the address of pointer 2.
So which address does it modify? You already got chocolate.
I won't get another one?
You can get it.
Okay.
Anyone else want to try? Okay. What does line 19 do?
Changes the value of the address pointer 2, which is 503 to -6.
Which value is changed? Which address?
It'll change
500.
Which one? What does line 19 do?
Change the value of A.
Change value of A. Why? Because
500 is address of
Because 500 is the address, you are just going to modify the address, the value at address 500, and make it -6. Okay. You said. All right. Okay. How about line 20? Is line 20 legal? Do you get any warning or error message? No. So what does line 20 do? since it's the right hand side, right? So you take PTR2 as the address, the variable as address 500, read it, because the right hand side of assignment, read it, so the right hand side is going to -6. You assign -6 to C. So this becomes -6. Alright, line 21. Is line 21 legal? It creates another pointer, PTR3. Since I have not initialized PTR3, it is garbage for now. So line 21 is fine. How about line 22? Somebody in the back. Line 22, is line 22 good? Is line 22 good?
Yeah, because the address of A is stored in.
The address of A stored in PTR3, is that good?
Oh, I thought it's not good.
Yeah, go ahead.
No, because PCI agrees, char and chase, so.
Okay, so PTR3 is kind of far, let me try. Oh, sorry. Okay. Because A is integer, PTR3 is character star. So you have time mismatch. So line 22 will give you a warning message. Okay. Now PTR3, line 22, don't worry about line 23, since line 22 is already a problem. Some people ask me, what if I really do line 22, what happens? The program behavior is undefined. Line 22 has a problem because A is an integer and PTR3 is a pointer to character. You have a type mismatch. What happens to your program? Undefined. Means your program may do sometimes may look okay, sometimes may not. Every time I teach this, some students say, I always get 1 or 2 students asking me, what really happens if I do that? Does anybody want to know the answer? Okay. And my response is this. You know it's a problem. You know something is wrong. You don't have to do it. Just like you don't have to jump out from a 10-story building. Am I going to break my leg or am I going to break my arm? Please don't try. There are better ways to use your time. You know it's a problem, don't do it. Okay. Is that okay? All right. Yes.
So in the first place, if the int A was actually character A, so line 22 was fine.
If line 9 is character A, yes.
And then what happened at the line 23?
If you change line 9, if you change line 9 to character A, first it is legal. Yes, because character, this can store from 0 to 255. So line 9, if we change to character, that's fine. And then if that case, line 23 will change A to the character A.
And number 5 is just treated as just character.
5 is an invisible character. It is a character, but it's invisible character. Does everybody know what's ASCII?
Yes.
Okay, do I need to talk about it? Raise your hand if you don't know what's ASCII. American Standard Code for Information Interchange. Some people also call it ASCII. Raise your hand if you don't know. I will talk about it. Everybody knows? Okay, I don't talk about it. Alright, so we have seen pointers. Why do I talk about pointers? Let me go back to... Yes, go ahead.
What is the warning that gives on the line 22?
What's the warning on line 22? Time mismatch. It's something related to time.
Like, does it say,
Okay, you really want to see. Alright.
他用这个就改过它。
I actually don't know what will happen. Okay. Another thing I want to tell you is you should always use a text editor that will do indentation. that will automatically format your code. I've seen many cases where students, they don't format your code, they have a mismatch brackets, and they cannot find. Once your code gets bigger and bigger, you want to use good tools to do that. Emacs is the editor I prefer to use. How do I do indentation? I simply mark and press tab. I'm done. Or then you can say if a equal to 5. See, it's automatically indenting code for me. C equal to okay. As I'm typing, it will try to put the code in the right place. Why is that useful? Because once your program gets bigger and bigger, sometimes you forget that. And if you don't have indentation, and I've seen many people's code like this, I don't even know how they can live with that. Don't laugh. I've seen many people code like that. And they try to debug this code. I don't know how that can be done. Okay. So in Emacs, mark the code, press tab. Then it's very obvious you are not closing this bracket. When you have a mismatched bracket, compiler can easily give you a few, like 20 error message, because compiler doesn't know how to do. Okay, so you want to see what happens to that line? I talk about -c in a moment. Okay, so warning assignment pointer, which line is that? Line 24. Incompatible pointer type. Okay? What's -c? What have we talked about related to GCC so far? What's minus lowercase o? Output, you already got it. Okay, someone else. Yes?
Optimize?
What?
Not optimize.
Minus lowercase o.
Minus lowercase o is I just forgot it.
In GCC,
In GCC.
it names the output file.
Name the output file. Okay. Can you pass? I don't. Name the output file. One more. Okay. So give me 2 ways to turn off warning messages. Anybody? Minus WALL and
W shadow.
W shadow. Okay, you get the last one. Okay. -c means this is not a complete program. It's only part of the program. It's called compiling. So why do we need to do things like this? You have to imagine you have a very big program. You have many files. Many files. If you modify one line, I'm going to rebuild the whole program altogether. If you ever have experience compiling a very big program, it can take minutes or hours. How many of you have experience compiling Linux from source? Nobody. Okay. I have. It took more than an hour. So for people that are not patient, like me, I don't know about you. I hope you're not very patient, so you try to do this quickly. In the right way, okay. Let's say, okay, if you have many files, you modify only one, why should I rebuild the rest of the program? So they create a concept called compile and a link. You take a .c file, use compilation, create what we call .object file. And this one is GCC -c. -c says this is not a complete program. So don't try to build a complete program. But you have done some work so that you don't have to when you want to rebuild the program, you don't have to rebuild the program from scratch. Then after you have the object files, you have many object files, then you create an executable. So when I did -c, in a very simple way to think about -c is you are checking the syntax. That's what I was doing. I'm not trying to create an executable. So I'm sure some of you will ask me, what happens if you remove -c here? That's right. You want to see the answer? Okay. It should say that you cannot find the main function. Oh, because it has a syntax error, it doesn't even try to do the next one. If I don't have a -c, then it will actually try to build it. Let me modify it. Get rid of that error message. Keep only the warning message. NULL is defining stdio.h. It says you cannot find. So without -c, it thinks this is a complete program. In a complete program, you need MAIN, and it says I cannot find it. If I use -c, it says this is not a complete program, so don't try to treat it as a complete program. Therefore, you see fewer error messages. Yes.
When you say GCC -c and then the file name, is a .o file created in the folder?
Yes, that whole file is created. Yes. Okay, this is too much, but this is created. You probably know ls, right? List. There's another command called -t that will list files by time. Most recent will be on the top. And then head means show only the top 10. Oh, I should do -l. So this one will show the top 10, the files, most recent top 10 files. So you can see that all is created. Now this vertical line here means pipe. Pipe means you take the command from the output from the previous command as the input for the second command. Hello? Okay? So that's a useful thing to do. Sometimes you have an output from one program you want to use as input from another program. This is called pipe, the vertical line. Okay. So, does that answer your question? What happens to that? What error message you see? Okay. Any other questions? Yes.
So the command GCC -c and the file name, we can use it for our the assignments, right?
You can use for your assignment. Yes.
Like
For checking syntax error.
Answer.c, like answer 02.c.
So this is what you are going to do. Since we told you to do GCC answer.c and that's a PA02.c and -o PA02, right? This is what we told you to do. You can do the following. You can say GCC -c answer.c. This will generate answer.o. And then you can say GCC -c PA02.c, and this will generate PA02.o.
And it's only checking the.
Then you will say GCC answer.o PA02.o -o PA02. This will take the two object files and create an executable. Yes?
When you say GCC -c and then file name, can we also say -o and give the option?
Yes, you can here you can say -o, give some name, but you probably won't do that.
Yeah.
because you should have a match. If you give a name that doesn't match, you are creating confusion. But it's allowed. Okay.
And then that PA2 and the PA2 at the first line will be same or
Which one?
at the first line.
You mean this line?
Yeah, making bar.
This one does not create object file. This one will create object file, then it will be deleted. In the middle, it will be deleted. Now you may ask, so what's the advantage of doing this? This is so much work. As I said, if your program gets bigger and bigger, you have many .c files. If you do this way, it will take a long time to build an executable. If you do this way, if only one .c file is changed, then you will generate only one, modify only one object file. So it will be much faster. Now understand, many of you will say, well, okay, so it can be faster, but do I need to type the whole thing? That's too much to type. There's a set tool called the makefile. We'll talk about that sometime later. Makefile is designed to do that for you. So you only need to type 4 letters, make. Make is a command in Linux. And make will go to find a particular file called the makefile. By convention, the first letter is M, capital M. You can do lowercase m, that's also fine, but most people use uppercase M. And makefile will specify the rules. So when you type make, you will try to find which C files need to be recompiled. You'll do this all for you. We'll talk about makefile sometime later.
When we do the -c, do we need to put like the -wr and -w shadow
Yes.
in front of it?
Yes, you should. Thank you for reminding me. You probably want to do -g as well because you may want to debug your program. Thank you for reminding.
Do you have the mask line as well? And we are creating the executable?
Yes, you should do -g after every GCC command. Okay. So, I give a very long answer to your question. What's the error message? So as you can see, you will say type mismatch. Alright, any more questions? So why do we talk about pointers? There are many reasons to talk about pointers. But one of the reasons is each function can see its own friend. Only. You cannot see the friend of the coder. So when you have a function f, let's say I have an integer a, and sometime later I have a function f2. And if I have integer a here, and say f something, this a and that a are different. Why are they different? You can simply change the name to something else as long as you change everywhere inside the function, the program will do exactly the same thing. So if you have an f2, this is a friend at f2. So f2 has a. And then if I call function f, as you know, you should have a friend for f. And that also has a, because that's an argument. This a and that a have nothing to do with each other. As I already said many times, in computer, symbols are completely destroyed. Computers do not care about symbols. Computers only care about address and the value. If this a and that a have different addresses, they are not related to each other. If you want the function to do something, obviously you probably want the function to change something. Otherwise, you call the function and nothing happens. That frame gets popped. Nothing happens, right? Whatever you do inside the function has no effect after the function returns. So what do? One way you can do it is you return something. So you can say integer f, it does something, and you will return an integer. let's say 5. And then in another function, consider you have integer x, and you do something, you say integer f equal to f. That way, you change x to 5. You can change one thing in your coder. What happens if you want to change 2? You want to change 2 things in your coder, then you're out of luck. So give me an example when you want to change 2 things in your. One example is a swap function. Swap function takes 2 arguments, argument 1, argument 2. It does something inside. And then in the function calling this swap, let's have integer x equal to 2, integer y equal to -4. I'm going to call swap. Something related to x, something related to y. And here x is -4 and y is 2. This is what I want. By calling this function, the variable x and y are changed. So how can we do that?
Send address.
So let me show you the very first version, and it is wrong. The first version I do is swap. I say integer u, integer v, and I say integer t equal u is v is t. And I call the function swap f. I say integer x equal to 2, integer y equal to -4. And I call swap. Remember type. This one integer, so I need to give integer. So that's the first version of a swap. Let's see whether it works. I have a frame f, x, y. So this is the address. Let me give 300 as address. It's 2. 301 is -4. I'm going to call swap. So I have return location here. This will be my return location. This function does not return anything, so there's no variable address. Then I have an argument u, argument v. They also have their address. Let me just write 400/1. Argument u is going to be a variable x, so this will be 2. Argument v will be y, the variable will be -4. A local variable t, I say assign u to t, so t will become 2, this line. And I say assign v to u, so v is -4, u is 2, so this becomes -4. Then the last line says assign t to v, 2, so this becomes 2. So inside swap function, u and the v, their variables are changed to -4 and the 2. When the function returns, the frame is swapped, x, y are not changed. So it's not good. Okay, I give you a little bit time to think. You swap the variables inside the function, but after the function finishes, the frame gets popped, and x, y are not changed. Any question? I could change one thing in the coder, but only one thing, using return. I need to change 2 things, I'm out of luck. Any question? So one way to solve this problem is, instead of giving the variable x, y, I'm going to give the address of x, y. So this is another way to write the swap, and I will explain to you how that works. And if you want to call this function, you have function f. It will be integer x equal to 2, integer y equal to -4. When you call swap, you need to be careful about the types. This one, a pointer, is a pointer, so you want an address. You need to give an address. As we have seen at the beginning of the class, if you have a time mismatch, you'll give an error message, a warning message. So how does this work? I frame f, x, and y. I row 300 here is 2, 301 is -4. That's before I call the swap function. Then I call the swap function. I have a return location is here. Return location is after the function finishes. This function has no return variable, so I don't have a variable address. I have an argument u, v. So suppose I put 400 here, 401, 402. So the variable v will be an address because I'm saying integer star v. So the variable v will be an address. This will be an address. The address is the address of x, so this will be 300. Because I'm giving address of x. Why are you not taking notes? You think you'll remember this?
Maybe.
I don't believe you. I have taught more than 1,000 students. There was only one student that didn't take notes and got A+. Only one. Okay. I hope you are the second one, but show me. Okay. Watch is not learning. Okay? You pay tuition?
Huh?
You pay tuition?
Yes.
Okay. You know how much money you spend per lecture? Have you calculated?
No.
Okay. Why don't you do that calculation and tell us next class? Is that okay?
Yeah.
Okay. Who has calculated how much money you spend per lecture? Okay. I'm going to call your parents and say, thank you for paying my tuition, but I didn't take notes. And I forgot 50% of what's in the lecture. Okay, so x is, we'll give the address of x. We'll give the address of y, so this will be 301. This will be address of y. Local variable t. T is an integer. T is not a pointer. And we'll say t equal to star v. Follow this rule, star v on the right side means I go to read the value of a v, so that's 300. I will go to the address of 300 and read that value. That means t is 2. So t becomes 2. Yes, please.
This is the RLV,
Which one?
the R.L. Using it from the swap.
This RL,
Yeah,
return location. Means the function will continue, the program will continue after the function call here. Okay? Any other questions?
It can be a void function, right?
This is a void function.
Oh, okay.
Okay. So t equal to star v means t equal to 2. Because v value is 300, go to address 300, read the value 2, so that's 2.
Is this another wrong function?
Void, swap is another function.
No, I mean, this is another type of like not making sense function. Or is this function gonna work or not?
This function will work. Let me show you. Okay, so I say star v equal to star u equal to star v. Let's worry about the right hand side first. Star v, value is 301. Star v on the right side, it means I'm going to read the value from 301. So this is equivalent to -4. The right hand side is minus 4. Take 301, go to the location of address 301, read the value is minus 4. Then let's worry about the left side. Star V, star U. Star U is on the left hand side, so I have used value as 300. So I go to 300, it's on the left hand side assignment, so it means this becomes minus 4. That's this one. Now the next line says star V equal to T. V is 301, T is 2. So it basically this says something is 2. Assign 2 to something. Star V, V is 301. Star V means I go to 301 and modify this to 2. Then when the function finishes, when the swap finishes, everything in the frame gets popped. So that is gone. What happened to x, y? They have been swapped. I'm sure all of you have heard this word. Have you heard this word? What does this word mean?
A phrase that doesn't actually, a phrase that doesn't reflect, doesn't mean what it reflects to.
Does it reflect to someone else? What does this word mean? When you learn a language, you must have learned many idioms, right? Give me an idiom. Give me an idiom. What do you do in the morning when you wake up? We like the idiom, right? Anyone want to explain what idiom? Idiom is a set of words that give you certain meanings. Is that a reasonable explanation? Like you wake up, you get onto a bus, get on. Okay, you get rid of this paper, get rid of. Why am I talking about this? There are certain combinations of words that have a meaning, and you use them so often, you need to know. What does it mean by wake up? Wake is a word, up is another word. What does it mean by wake up?
To awaken.
You were sleeping and you are no longer sleeping, right? Swap is an idiom in C language or any language. It's something you just need to know, because if you do not know, it's very difficult to carry out a conversation. Does that make any sense? Imagine you have no idiom in a language you are learning. You don't understand. You understand the word wake. You don't understand. You understand the word up. You don't understand, but you put the two words together, wake up. It's a bit difficult to carry out a conversation. Does that make any sense? So swap function is an idiom in programming. Can you look it up? Yes, you can look it up, but it's going to take time. This function conveys so much information you need to understand. You need to know it by heart. I'm not telling you to just memorizing without understanding. You have to understand, but you understand it so well, you understand it in and out, up and down. What other words I can use? Okay.
Inside out.
In what?
Inside out.
Inside out, whatever. You need to know swap so well, you can write it with your eyes closed, without thinking. In fact, there are, and this is one of the favorite questions in case you want to go to get an interview or something. Oh, you cannot see that. There are 15,552 ways to write swap function, and 15,551 are wrong. There's only one way, one correct way to write it. And 15,551 incorrect way to write it. This is in page 137 in the class note. How many are going to schedule an interview in the next few days? Just one? Nobody's looking for summer intern? Is anybody looking for summer intern? Okay. Student told me questions like this is a frequently asked question. They will write a function and ask you, does this work? And in this handout, I gave you some examples. Any questions?
How do you know it's 15,500?
I show you how to calculate it here. I show you how to calculate it here. I could make a mistake, so tell me if I'm wrong. Okay. Don't trust everything from professors. Don't trust everything from anybody. You need to think, right? Okay. So we have talked about swap. As I said, swap is something you need to know so well. You just memorize it. I'm going to give you a time to think. Figure out where you need to put star. I give you a few examples. What is wrong? Okay. What happens if I don't have the ampersand here? Yes?
The swap function will have no way of knowing the memory address of X, so you can get to the
Do you get the runtime error, or do you get the compiler warning, or
segmentation fault at some time in the program.
segmentation fault because you put 2 here, right? And you are going to, this line is going to try to read the value at the memory location 2, right? Okay. What happens if I don't use star there? What if I remove this star?
T becomes 2.
What?
Oh. T becomes 2.
T becomes 2? You are shaking your head. Go ahead.
Wouldn't T take the memory address of U?
Take suppose I still have an ampersand here, okay? So this will be 300, so T will get 300. But is that a good thing?
No.
No, because 300 means address. You are assigning address to integer, so compiler will say you're probably making a mistake. You'll get a warning. Right? How about I remove this? U equal to V equal to U. Do I have compiler warning or error? Yes. Error?
Not there.
What's the type of V? What's the type of U? It's an address. It is legal type.
Yes.
Yes, you assign address to an address. You assign the value of address to, you basically modify, change it to 301. This line is legal. You don't get a compiler warning or error because both sides are pointers. But that's wrong. Because after the function returns, x, y are not swapped. Similarly, you can put, how about if I put, can I write this line and modify to V equal to T? Is that legal?
Okay. Is that N?
Ampersand.
No, that's
Is that legal? What's the value of V? What's type of V?
address.
Address. For integer.
Oh, that's
And what's ampersand T?
address.
Address of
T.
T is integer. So this is also address. So this line is legal but doesn't do what you want to do. Are you convinced there are 15,000 now?
Yeah, I know how you.
You'll say, remove star, what happens? Add star, what happens? Remove ampersand, add ampersand, what happens? So swap function is a function that tells you many things about pointers. Okay. Any questions? All right. So let me talk about type a little bit more. Let me get rid of that. Okay. When you get address of A, you need to add one star in front. The end of a class last week, somebody asked me, what happens if I want to have an ampersand PTR? You can do that, but you need to add one more star. So this is the rule. You have a type of something that's put X. You put the ampersand X. The type of this will be the type plus one star. So that's the reason you can have an integer star here. Because your ampersand A, PTR has to be integer star. You want to do ampersand PTR, PTR is integer star. You want to get the address of PTR, you add one more star.
What is 2 stars though?
It's a pointer to a pointer.
Could you please explain more?
Sure. Sure. But just understand it so far, I'll give you an example. Why do we need star star? Let's say I want to change a pointer in a function. So if I have a function, and I have another function, I say f2. I want to change f. I want to change p inside the function. If I want to change something, when I call the function, I have to give ampersand. I give the address. So the rule is if you want a function to change something, you need to give the address from the caller. Now let's imagine a situation we don't give address. We'll say f and p equal to something. Then I call the function as an f2 let me say p2 here. And I say f p2. So suppose P2's value, I can say P2 equal to ampersand A. So I put the integer A here. So I have A, P2. Let's say this is 100, this will be 100. Now if inside function f, I say P start with P2, so this will be copied to 100. If I say P modifies change to something, I'm modifying this one. After the function returns, P2 is not changed. So if you want to change P2, you have to give an address. Now I'm sure most of you are asked, why do I want to change P2? Right? So we are going to talk about another piece of memory. It's called heap memory. Stack memory is managed by compiler plus operating system. You have no control. You cannot say, I want it to be on stack memory. I don't want this. If you create a local variable, it will be on the stack memory. You have no choice. If you have a function has argument, the arguments will be on the stack memory. You have no choice. And stack memory is always first in, last out. Means whatever you do will be on the top. You cannot say, I don't want to do anything on the top. I want to do something below. You can do it only through pointers. But in many cases, you want to have additional amount of memory. For example, you want to sort student database. How much memory should you allocate? How much memory should you allocate for student database? You don't know. And you have to see how many students are in the database. Right? You have no control of the size of memory if you use only stack memory. So heap memory gives you freedom. You can allocate based on your need, and you have to release when you don't need it anymore. For example, you ask a user to enter some data. The user may enter 5 numbers, may enter 10 numbers, may enter 500 numbers. You do not know what the user would do, so you cannot in advance say I'm going to have 5 numbers. You don't know that until the program is running and the user tells you. In that case, you allocate memory when you need. Heap memory is another piece of memory. It's separated from stack. So your computer memory will look like this. It's managed by the operating system. Stack memory is, as we have seen, basically it goes up, goes down as you call a function or when the function returns. Heap memory, you say, I want a chunk of memory, it will be yours. And it will be yours until you release it. So you can call a function can allocate memory. If you don't release it, the piece of memory is still yours. Now, of course, freedom comes responsibility. You must have heard that word, right? That phrase. You have to allocate, you have to release. You cannot use memory if you don't allocate. If you don't need to use it, you have to release. That's a major source of headache in 264. I tell you certain rules to follow to make your life easier. If you don't follow those rules, you'll spend a lot of time debugging. So stay with me. How do I allocate memory? You will create a pointer. You will say something like type, a pointer. For example, you can say integer. Type can be integer, can be character, can be double. Later on we'll talk about different types you can create. And you'll say PTR equal to malloc, memory allocation. This says I want to allocate, create an array of integers And the array has so many elements.
Question
Yes, please.
about how the malloc works. So let's say PTR already has 50 bytes of distributed memory, okay? And you do malloc size of int, which is 4 times, like, let's say 2, so it's like you want to allocate 8 bits of more memory. Is it going to be 58 or just 8?
There will be 2 different pieces of memory.
Oh.
Let me draw it for you. Remember I said stack and heap are 2 pieces of memory. Okay? The boundary is set by operating system. Depends on the operating system. Some operating system allow the boundary to move.
Move a bit, right?
Sure.
No, up.
Up. Okay.
Thank you.
The boundary between heap and stack depends on the operating system. Some operating system has fixed boundary. Says stack is stack, heap is heap. You cannot mix them. Some operating system will say, if you need more stack, I move the line a little bit. If you need more heap, I move line the other way. So that if you need more heap and you don't need much stack, I give you more heap. Depends on operating system. Most operating system, I should not say most, many operating system, the boundary is fixed. Because allow the boundary to move, make it harder to write the operating system. So the operating system symbol says, this is the boundary. If you ask for too much for heap, it's your problem. I break into whatever you decide to do, and the boundary doesn't move. Okay? So this what will happen. When you write integer PTR, it must be inside a function, right? So it will be in your call stack. It will be a local variable somewhere. It will be in your call stack. Malloc will return the address from the heap memory. Let's say the return address is 10,000. So this will be 10,000. And then how many will be there? That depends on how much you ask for. There will be so many elements. Each element will be able to store 1 integer. After you do this, then you can say PTR 0 equal to 4. What that means is, when you say PTR square bracket, that means this line means you take PTR's value as an address and add the index to get a new address. Then depends on is the left side or right side. If it's the left side, left, you write to the address. It's the left side, right side, you read from that address. So when you say PTR 0 equal to 4, you modify this to 4. You take PTR's value is 10,000, and index is 0, so you get 10,000 plus 0, you go to this address. It's the left side, so you make it 4. You modify, you write 4 to this address. If you say PTR 2 equal to minus 3, so this will be 0, 1, 2, so this will be minus 3.
What if the PTR already is an assigned array with lots of memory?
If PTR already points to a piece of memory and you do not release that piece of memory, you lose that piece of memory. It's called memory leak. We'll talk about next lecture. Suppose
I want
currently
to
PTR.
I mean, like let's say I already have 50 values, but I need more memory to allocate new.
Then you have to release the old one You have to,
release.
yes. We'll talk about memory leak next lecture. So this is how you can allocate memory. If you don't need any more, you need to say free PTR. That says get rid of this piece of memory. Once you release, you can no longer access. If you say free and say PTR 0 equal to 2, you may or may not get segmentation fault. Sometimes you get, sometimes you don't. And that kind of bug is very hard to track. So after you release, don't use it anymore. In terms of syntax, some old book will tell you you need to say PTR integer star malloc. That is not needed. You'll see that in old books. The new books says you don't have to do it. In fact, it's not recommended. So you will not see that in new books, in the new standard. Yes?
Here you assign a feature and area plan any and right?
Yes.
So when you free memory, can you just say I want to free the last 5?
No, you cannot. When you release memory, free does not have length here. So when you free memory, you have to free the whole thing. That's the way C is designed. One more thing here is the type here, integer and integer, they have to match. If they do not match, you are asking for trouble. And you don't need to know why you are asking for trouble. Just remember, don't jump out from a 10-story building. You don't need to know if you are going to break your leg or going to break your arm. It's going to hurt. Don't try. All right, I talk about this on Wednesday. Yes?
You can do that in like multiple times.
Which one?
The allocating memory, like.
You can allocate, release, allocate, release.
So that you can do for allocate for PTR 1 and PTR 2 and PTR 3.
Yes.
And then you have to free them all, right?
Yes.